are your notes. So make sure, you know, you've got different colors out that you can use and do different things, right? You can use pen and stuff in here. We are going to need a calculator. Some of the numbers are a little big today. Tomorrow, they're definitely going to grow on us. So make sure you bring a calculator tomorrow. Oops, that's a little far away. If you have one today, that's fine. If you don't, I'll do the calculations for you. There's only a few today that are big, but definitely grab one for tomorrow. We'll need a calculator. All right, you should have a highlighter with you for sure. We're gonna highlight a couple of things along the way. Which pen do I like? I don't even remember. All right, 10-1. Let's jump into this, guys. These are simple, very simple ideas today. I hope that some of it will kind of reawaken some of the memories that you had from middle school and you'll be like, oh yeah, I remember doing this, okay? If you're really struggling with any of these things, I would say get yourself some props. I have some props in here because you'll notice like we have a spinner. Like you might be able to find a game spinner at home. That one's not as hard. It might help some of you guys because they talk about like dice. It might help you to have one in front of you. How many of you guys actually play some board games over break? Cards? Anybody play cards? Games? I love card games. I don't know what it is. I don't like war. I like ones that you have to like actually can have some strategy at. But like if you're not sure about a deck of cards, decks of cards show up in here too. So that might help you if you need to look at that. Okay, so sample space. Sample space. Let's start out by highlighting a few of these definitions. It says an experiment is a situation involving chance. We should all be well versed in what an experiment is, right? You guys have done that before. An outcome is the result of a single performance or trial. So these are the outcomes. And then all the possible outcomes, that's your sample space. The set of all possible outcomes, that's your sample space. You have to understand what your sample space is, and it changes depending on what you're doing. So that's what we're going to look at today. And we're going to also decide if our sample space is finite, right? Does it end? Does it have an ending? Is it infinite sample space? Can we not even count the amount of outcomes that there are? And then they have something down here that's special. You might want to highlight this one. An infinite discrete sample space has outcomes that can be arranged in a sequence or counted but go on indefinitely. And we'll talk about what that is. So you're going to need to know what these terms are. I don't think they're that bad once we see more examples. All right, so how to define the sample space. That's all that this first little lesson is about, how to figure out what's in your sample space. So let's say we're tossing a dice, right? A die. They say die. That means there's just one of them. How many sides are on the die? Easy answers today. 6, right? And the numbers 1 through 6 are on there. So those are the different outcomes that you could have in your sample space. This is your sample space. 1, 2, 3, 4, 5, and 6. Simple, right? Part B, it says, what is the sample space for the event of rolling a prime number? So now we're changing it up a little bit. The sample space if we're going to have a prime number. Guys, somebody define prime number for me. We should know what that is. What's a prime number? Oh, what is that thing? Yes, a number that can only be divided by itself or 1. So starting with prime numbers, we've got 1. What's wrong with 2? 2 is a prime number, right? 2. What else? 3. Oh, we can write them down. 1, 2, 3. Is 4 a prime number? Is 5 a prime number? Why do they not have 5 on here? Is 6 a prime number? So there they go. Why did they not have, oh, less than, so no, that's right. They should have the 1, 2, 3, 5, 5. That's weird. Okay, I'll let that one slide. I'm gonna go ask Miss Hendry what she thinks about that. All right, so that's a pretty simple idea, right? Turn the page, let's look at some more. Okay, so this next example, they're asking you to, because that was a very simple idea, like one die. Now we're going to get some things that are a little bit more complicated. And when things get a little bit more complicated, you need to organize them. So you can organize them just by listing them out. You can create a table. And then I bet you've done this before, the tree diagram. Have you ever seen that before, a tree diagram? So they give you this one example in number 2. It says, Kemby has a black hat and a red hat. He chooses one hat for each day, Saturday and Sunday. Represent the sample space for his experiment by making an organized list, a table, and a tree diagram. So we're going to represent the same list 3 different ways. Make sense? So when you look at this list and they put these in like little ordered pairs, why are there 2 of them? Who can tell me that? Why do I have 2 little ordered pairs in here? What is this? What do you think R stands for? Red and red, right? Why are there 2 reds? Yeah, this is, he chose a red hat on Saturday, he chose a red hat on Sunday. So that's one way that this whole event can happen. You with me? Does that make sense? Or he could choose a red hat on Saturday and a black hat on Sunday. True? Or he could wear black hats both days and then they're missing one. What's another way that he could do this? He could do the black hat on Saturday and the red hat on Sunday. Now, did we get all the possible combinations for wearing the black and red hat on Saturday and Sunday? Yeah, we did. Here's another way, and I think I like the table a lot, but that doesn't mean that you like the table a lot. So here they have Sunday with a red or black, and they have Saturday with a red or black, and then they have the different combinations, right? Red, red, and then here we have black, red, and then we have red, black, and black, black. But you can see it's just another way to organize, and you get the same sample space, right? There's 4 different ways to get those. Is this too easy for you guys? Or is this just what you need the first day back after break? I don't know. Okay, and then comes the tree diagram. So the tree diagram has got the outcomes starting with Saturday's hat choices. So the first branch of the tree is on Saturday. You have 2 choices. You can have a red hat or a black hat, right? And then on Sunday, depending on what you chose on Saturday, Sunday you could do the red or the black, right? Or over here you could do the red or the black. And so when you go down the tree, it gives you the same sample space that we've seen before. So our choices would be red, red for this one, red, black for this guy, and then black, red, or black, black. So you're just going, some people when they make the trees, they make them going out this direction horizontally. These people did it vertically. It really doesn't make a difference because you get the same exact idea, okay? All right, so see if you understand this. This says a geometry teacher always breaks her class up into red, yellow, and blue groups for class projects. Represent the sample space for the next 2 class projects by making an organized list. Enter the outcomes to complete the organized list. So I'm going to let you fill those in, and it's 2 class projects, right? I don't love this example because it doesn't seem very real. I'm a geometry teacher and I've never done that, but maybe I need to do something like that. I don't know. Okay. So we've got red, 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 yellow. What'd you put for the third blank? Janine, did you put anything in that third blank?
Red, blue.
Red, blue. And then we have yellow, red. And what'd you put in for the next blank, Julie? Yellow, yellow? Would it be okay if I put yellow, blue? Would it make a difference? Yeah, it's fine. So we could do yellow, yellow. And then we need yellow, blue, right? And then we have blue, red. So Gigi, what should come next after blue, red?
Blue, blue.
Blue, blue would work. Or you could have put what, Grant?
Blue yellow.
Blue, yellow, okay. All right, so that's project 1 and project 2. So that sample space is a little bit bigger because there was more choices.
Does it matter, like, the order?
It does not matter the order. So think about this, it's a sample space. So it's all the different outcomes that she could get, so the order doesn't make a difference. Okay, we'll tell you when order matters. All right, any questions on that one? All right, turn the page. All right, so now we're gonna look at these definitions. Finite and infinite sample spaces, and we've got to fill in the blanks. So part A, it says a marble is drawn from a bag that contains 3 orange marbles, 5 green marbles, and 4 blue marbles. There are only how many possible outcomes, guys, of this experiment? If I stick my hand in the bag, how many different ways can I take a marble out? 3. So there's only 3 little outcomes for this one. 3 in our sample space. So do you think this is finite or infinite?
Finite.
Yeah, it's finite. You're going to draw a marble and that's it. You're done. There's only, one answer, only one outcome that you're going to get in that sample space. So this is finite. Part B, a spinner with 4 equal parts of green, blue, red, and yellow is spun until it lands on yellow. How many? There are blank number of possible outcomes, David. How many possible outcomes on the spinner?
4.
4. Now this is kind of key. They want us to spin the spinner until we get yellow. So it says blah, blah, blah. So the sample space is finite, right? Because the experiment ends after a certain number of spins, when the spinner lands on yellow, the sample space is what we're going to call discrete. Because it's going to actually end, right?
The number of spin end, or like when you land on something? Like, is it asking how many times that you're allowed to spin it? Or
Well, it's discrete because like you spin it and it's done, and you spin it and it's done, and you spin it and it's not like it keeps spinning and spinning and spinning. It's not continuous. Okay. Part C, a ball is thrown into the air and its height is recorded in inches. How many possible outcomes are this in this experiment? Throwing a ball into the air, how many different outcomes can you get for that height?
Infinite?
That's infinite, yeah. This one's a little weird. You don't really have infinite outcomes too often. Usually they're more finite. That's more realistic. Okay, so this one is infinite. Why do I write it twice? You can continue to record heights of the thrown ball indefinitely, so the sample space is continuous. That one we don't do very often. We're more likely going to be in this realm up here, where we're doing things that are going to end. Okay, so this is something that you've probably done in middle school. It's called the fundamental counting principle. You want to highlight that or underline that. And it's a very, very simple thing. It's a very simple thing. All right, and we're going to highlight what it is under where it's the words. It says the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes for each stage or event. This is a very, very easy idea, and this is where you might need a calculator today. Okay, we're going to multiply the number of outcomes for each event. So turn the page, we have some easy examples here. All right, Santiago lists the number of sections available for the courses he will take in his first semester of college. This is something you will be doing in the very near future. How many different schedules could Santiago create for this semester? So look at the different courses that he's taking. Art history, and there's 6 of those. He's going to take French, and there's 5 different classes available for that one. He's going to take a math class. There's 9 different classes offered. And art classes are 4, and English is 6. And by the way, that's a lot of classes for a college semester. Usually you take like 4, maybe 5. That's a lot for Santiago. All right, so all he's going to do to find the possible outcomes, and they did it for you down here, is he's going to multiply what's the sample space for each event. So for art history, there's 6 sections, so he would multiply that by how many different sections there are for French, and then math, and then art, and then English. So you just multiply these up, and it gives you the total possible outcomes. That's your fundamental counting principle. That's all you do is multiply it all together. Okay? Now, normally you see this in a type of question that looks more like the next one. So the next one, this is like maybe something that you have when you go to buy things online. I don't know. Am I in there? Can we see the whole thing? Oh, I need to move it up. Sorry. Okay, so it says a sneaker company lets you customize your own sneaker on their website using their most popular sneaker as the base. You have the option to customize the color of each part of the sneaker, excuse me. So you've got the base, the side, the toe cap, the sole, and the laces. And this is the main color. Sorry, oh, I missed the main color. So which is the best estimate for the number of possible customizations? Well, let's go ahead. Who's got a calculator? How are we going to find this? How many different customizations are there? Let's just go ahead and find it. I don't care about the estimate, really. You're just going to multiply. There's 20 different ways to do the main color, times 12 different ways to do the base, times 29 ways to do the side, times 12 to do the toe cap, 2 to do the sole. You guys with me? It's a lot. What'd you get? Did I miss a number? Oh, I should have looked at my display. 20. Make sure I hit times. Oh yeah, I got the same number. I got... I got 4,844,160 different ways to create this sneaker.
Yeah.
Did you get that? Part B, yeah. You know what I think we'll find out tomorrow? I saw on the way in here that the Powerball is up to 291 million. That was on a billboard when I drove in. I'll help you figure out your outcomes for that tomorrow. This is why you don't waste your money on the lot. All right, turn the page. Okay, so this is going to be your homework for tonight, and we're going to go on and do a little bit more and see how much more we can get through. But you're going to do the, and guys, I'm going to let you write right on here. You're going to write right on this page. You can hand it in to me, okay? So you're going to do the page 185 and 186, 1 through 15. Now, these are quick. These should be quick, easy answers. This should not take you a lot of time, okay? Are we all right with it? All right, we're gonna keep going and get into some of the probability. So taking these sample spaces and actually figuring out. Going into lesson 10.2, probability and counting. So real quick, probability, guys, when you think of probability, what does a probability of 1 stand for? If I tell you a probability is 1, or you could call it 100%, that means that something happens all the time. So on the flip side, if I give you a probability of 0 or 0%, what does that mean? The event never happens, right? Everything else is in between these two numbers. Can you think of something that happens all the time? The sun comes up every morning. The earth is rotating. Praise God. Your heart is beating and you're breathing. So there's not that many things really in life that happen 100% of the time. A lot of the things that God has put into place, which is kind of cool, you see in nature happening and in your body. We don't even have to think about it. It just happens. But a lot of things that we're in control of, or things we think we're in control of, they don't really happen 100% of the time, do they? So everything else that we look at is going to be either between 0 and 1, because sometimes you look at probability as a decimal, and then other times you can change that decimal to a percentage. So right from 0 to 100%. And it doesn't matter which way you look at it. It doesn't change the probability. It's just another way to look at it. Okay? So if things are more likely to happen, right, those are things that you can count on, true? Things that you know are more likely to occur will be closer to the 100. Things less likely to happen will be closer to the 0, right, as we go through these. So this is Algebra 2, so this book takes into account that they believe that you have done this a little bit, so they jump right into the intersection and union of probabilities. I don't know if we'll get through both of them today. Intersection means what they have in common. So this is the symbol that you use for intersection. And so this is what things have in common. So you're looking at this highlighted area. So there will be an event A, and there will be an event B, and this is where the two overlap. All right, what they have in common, that's your intersection. And then you have the union. And when I think of union, I like the thing, the little symbol, because it looks like a U, right? So this is union. But this is everything. And what I like you to think about is when you think about when people unite and they get married, right? Don't they say something in the wedding vows about the union of two people? Am I making that up? I can't even remember right now. But think about it. So let's just talk about like when you get married. So the event of person A marrying person B. You're bringing everything together. So it's everything. Does that make sense? Now, if they have anything that overlaps in here, you know, a lot of times they're not going to keep the what overlaps. So they have down here a formula, but I can show you how to like think about this without the formula when it comes to the union, putting everything together. So let's take a look at what some of these look like, because I don't think they're too bad. So we're starting with intersection. So remember, intersection is only what they have in common. Only what they have in common. So it says a fair die is rolled once. Let A be the event of rolling an odd number. So we're going to do the probability first that we get an odd number, and let B be the event of rolling a number greater than 3. So guys, these things have to happen at the same time. Now remember, we're rolling one die, right? We're rolling one die. So when you roll the dice, the possible outcomes for event A are the numbers on the die that are odd. That's 1, 3, and 5, right? So that's event A. You get the odd numbers, 1, 3, or 5. The possible outcomes for event B, those are the numbers that are greater than 3. So that's 4, 5, and 6. So remember, this is this little symbol, this is intersection, this is what they have in common. So what do we get? Just the 5, right? So it's just one of the outcomes, so it equals 5. That's the only thing that they had in common is the 5. Does that make sense? So when you see the little intersection symbol, you think about what they have in common, okay? Here's another one for intersection, and I love how they made this for you. Most of the time, you're not going to have a pretty little Venn diagram like this. But this is super helpful. How many of you guys are not familiar with the deck of cards at all? Anybody not familiar with the deck of cards? Oh my gosh, you guys all are, or you're just not answering me today? Okay, so in your deck of cards, they go from ace to king, and you have 4 different suits, right? You have the clubs, the spades, you have the hearts, and you have the diamonds. Does anybody know how many cards are in the whole entire deck? Vicky? 52. So the whole, oh, it says it right there. 52 in the deck, but you should know that each of these, this is 13 here, 13 here, 13, and 13. You with me? Because 13 times 4 is 52. All right, so we got a card is selected from a standard deck, so that's our standard deck. What's the probability that the card is a queen and is red? The card is queen and is red. So from the diagram, we've got, oh my gosh, I don't even like going through all this stuff, guys. So queen and red, do you see how many there are possible to be queen and red at the same time? 2 out of how many in our total sample space?
52.
2 out of 52. So that's the probability. Now, can we reduce that number?
Yes.
Yeah, guys, if you can reduce your fraction, you need to. So it's going to be 1 out of, oh, I'm sorry. 1 out of how much? 26. And if you have a calculator, let's put that into your calculator. Do 1 divided by 26. And that gives you the decimal, which is 0.0384. What's that percentage? 38%, right? No. Yeah, 3.8%, sorry. So is that likely to occur? Is that an easy outcome, or is that a very difficult one? It's a difficult one, right? That number is very low. That's not close to 100, right? That one's not close to 1. That's a very small fraction. You with me? How many of you guys remember this probability thing? Okay, so that last problem on a scale from 1 to 5, 5 is hard, and 0 is not hard. Where are you at? Give me your hand. Where are you?
0.
You're at a 0. Anybody? Where? Hold up your hand. Show me where you're at. 1 to 5. 5 is hard, and 0 is not hard. Or maybe you're a 1, a 2, or 3. Where are you at with that problem? Grant, come on, vote. Practice for when you turn 18, when you can vote. What do you say, Janine? Is that hard or no? Is it a lot of words for you? A lot of new words? I'm sorry. You got a dictionary? Translator? Okay. Now we're going to go into unions. Unions. This is like they're getting married and we're doing everything together, right? We're getting married. We're uniting. So a fair die is rolled once. Let A be the event of rolling a number less than 5, and let B be the event of rolling a multiple of 2. Now, when you read that all together, it gets kind of crazy, doesn't it? We're going to break it down, though. So find A union B. A union B, or everything all together. So the possible outcomes for event A are all the numbers on the die that are less than 5. Give me all the numbers on the die that are less than 5, Josh.
4, 3, 2, 1.
He goes backwards for us. You're cute. Okay, there they are. There's only 4 different ones in that sample space. Now we need the possible outcomes for event B. All the numbers on the die that are multiples of what? 2. So Julia, what are our oh, they give us them. 2, 4, and 6. My bad. I'll get you in the next one. So now if we look at A union B, contains all of the outcomes that are in both, right? We're going to put them all together, are common to both. So now we're just going to list out all of them. So we've got 2, 4, and 6, and we've got 1, 2, 3, 4, and 6. That's our sample space. Are we okay with that? Right, try it for the spinner. I'm gonna let you read this one on your own. I'm gonna give you like a minute and a half to read that one and try it out. Okay, just look up when you're done so I know we're ready to go. Okay, A is the event that the spinner landed on the blue section. So for A equals, they put a 7 in there. What was the other number, Trinity, that you put in there? 15, nice. So those are the 2 sections that are blue. And B is the event of the spinner landing on a section with a number divisible by 3. So you've got in here 3, 15. What was the other number that you put in there, Annabella? 9. So now we're doing the union. We're putting everything together. So what was missing for the last blank, Carly? 15. Can we do the union and the intersection? Are we okay with these? The bell is going to ring on us, so we're not going to make it to the complement. Here's what I'd like you to do, people. So you've got the first 2 pages, and then you're going to do 193, and we're going to do, I'll put it on my CCA. We're not going to get to example 4. We're going to do just 1 through 10. And we'll do the complement tomorrow. 1 through 10 on the next 2 pages. So you got 1 through 14 and 1 through 10. So your book, boys and girls, you have to keep this. Make sure your name goes on it. Keep it somewhere safe. Bring it back tomorrow. If you want to rip out the pages and put them in your notebook. Oh, by the way, don't throw away all your old notes on the polynomials. You can get rid of everything else. Don't get rid of polynomials, okay? Have a lovely day. I'll see you tomorrow. You're doing it. Do that homework. Be awesome.